In this lesson, we are going to look at how to use long division to divide a polynomial by another polynomial. So let's get started here. This is going to require long division. So if you remember long division from, say, grade school, let's take, for example, dividing 674 by 7. Well, you would say, how many times will 7 go into 6? Well, it won't, so let's look at 67. How many times will 7 go into 67? Well, I think 9 times, because 9 times 7 is 63. We multiply back, 9 times 7 is 63. Then we subtract, and we get 4. And then we pull down a 4, and we say, how many times will 7 go into 44? Well, I think 7 times 6 is 42, so it'll go 6 times, with 2 left over. And what do we do with that 2? If we want to make a mixed number, then we put the 2 over the 7, and we have 96 and 2/7 for our quotient. That is the process that we are about to use here. So let's look, for example, at 2x squared plus 5x plus 7, all divided by x plus 2. What we do is we say, for a guess, we say how many times will x go into 2x squared? And what I want you to visualize is 2x squared over x. Whatever this term is on top, whatever this term is on the bottom. And 2x squared over x reduces to 2x, so that will be what we put for our guess. And then we multiply back. 2x times x is 2x squared. And 2x times 2 is 4x. Okay, now normally here would be the subtraction step, but since we're talking about terms of a polynomial, let's not say subtract, let's say change signs and add. Now you know that those two are the same, but it does seem to make a difference when we're dealing with terms. It helps keep us on track. So we are subtracting, but the way we'll accomplish that is we will change signs. See here, I changed signs, and we will add. Now 2x squared minus 2x squared, or in other words, 2x squared plus negative 2x squared is nothing. And that's what we want there. We want these two terms always to add up to nothing. And then 5x plus negative 4x gives us 1x. And after you subtract, then you pull down. And so now I'll say, how many times will x plus 2 go into x plus 7? So I visualize, for my guess, I visualize x over x, which is 1. So we'll put 1 up on the line here. And then we multiply back. X times 1 is x. 1 times 2 is 2. And then we'll change signs and add. And we'll get x plus negative x is nothing. That's what we want. And then 7 plus negative 2 is 5. And so 5, notice, now is the remainder, because there is not enough here for x to go in. And so we just say that 5 is the remainder. And just like we did with the mixed number, we put the remainder over the divisor. So we were dividing by x plus 2, so we put the remainder over x plus 2. So our final answer is 2x plus 1 plus 5 over x plus 2. Now here's one that has this old-fashioned kind of division symbol. So let's remember how you would have done this in grade school with just regular numbers. You would have put the first number inside the doghouse and the second number outside. So we'll do the same thing. And we'll have x plus 2 outside. Alright, now, to get us started, we say how many times will x go into x to the third? We visualize the x to the third on top, x on the bottom. You reduce that, you get x to the second. That's what goes on the line as a guess. Okay, now multiply back. X squared times x is x to the third. X squared times 2 is 2x squared. Now time for subtraction, so we change signs and add. X to the third plus negative x to the third is nothing. but 5x squared plus negative 2x squared gives you 3x squared. Now pull down. Okay, now how many times will x go into 3x squared? So we visualize 3x squared over x, we reduce, we get 3x. That's what goes on the line as our guess. Multiply back. 3x times x is 3x squared. See how those always match? And 3x times 2 is 6x. Okay, now it's time for subtraction, so we change signs and add. And 3x squared minus 3x squared is nothing, but 7x minus 6x is 1x. Pull down. Okay, how many times will x go into x? That's 1, of course. And then we visualize x over x. We get our 1, so we put the plus 1 here on the line. And then we multiply back. 1 times x is x. 1 times 2 is 2. Change signs and add. And of course this time we get a remainder of 0. Now that means that x plus 2 went evenly into this 4-term polynomial. And so the quotient is simply x squared plus 3x plus 1. Now if you wanted to check your work, remember how you used to check your work in grade school? You would take whatever you got for your answer and multiply it times your divisor, and when you multiply these two back together it should make the number you were dividing into. And sure enough, if you were to take the time to multiply x squared plus 3x plus 1 times x plus 2 and combine all the like terms, you would get x to the third plus 5x squared plus 7x plus 2. Okay, so here's one that I hope you will pause the video and try it on your own. And I'm going to assume that you have done that, and I'm going to go ahead and work it out here. So we put the trinomial under the box. We put the x plus 9 outside. We say how many times will x go into x squared? And we simplify and get x. X goes on the line. Multiply back. X times x is x squared. X times 9 is 9x. Change signs and add. 14x minus 9x gives us 5x. Pull down. How many times will x go into 5x? Well, 5. So we put 5 on the line. Multiply back. 5 times x is 5x. 5 times 9 is 45. Change signs and add. We get 0. That's a good feeling. And so x squared plus 14x plus 45 divided by x plus 9 is x plus 5. Notice that if you did the FOIL process on x plus 9 times x plus 5, you would get exactly x squared plus 14x plus 45 and no remainder. On this example, notice that the trinomial we're dividing into is not in the standard order. The x squared term is in the middle. When I get ready to set up my doghouse division work, I'm definitely going to want the highest power first. So let's just rearrange. We know we're always allowed to rearrange terms. And here, this problem is a little different than the others we've done because it does have a coefficient here. But you'll see that that won't make any difference to the steps that we use. Alright, so we'll say here, for our first guess, how many times will 2x go into 8x squared? Visualize it in fraction form and reduce. We get 4x. So we'll put 4x on the line here. 4x times 2x, multiply back. 4x times 3. Alright, change signs and add. And that'll be 0. 6x minus 12x is negative 6x. Pull down. Okay, how many times will 2x go into negative 6x? So we visualize negative 6x on top, 2x on the bottom. Reduce, you get negative 3. That goes here as your guess. Now multiply back. Negative 3 times 2x. Negative 3 times positive 3. Now change signs and add. And negative 12 plus 9 is negative 3. So this will be our remainder because there's not anything else to pull down. And this power degree, this x, is larger than this x because this one doesn't have an x. So negative 3 is our remainder, and we put that over 2x plus 3. Now for this one, we're doing x to the third minus 1 divided by x minus 1. When I write out my doghouse, notice that some of the terms are missing. X to the second is missing, x is missing. So I'm going to leave a space for those just to make my division easier when I get to pulling things down and all of that. So I've left 0x squared and 0x here so that every x power is represented starting with the largest one that was in the problem, and then I want to have a space for x squared and a space for x, and then here's my minus 1. Okay, I say how many times will x go into x to the third? Well, that would be x squared, put that on the line, multiply back, x squared times x, and x squared times 1, negative 1. Alright, change signs and add, and notice that 0x squared plus 1x squared is 1x squared. Now pull down, what am I pulling down? Actually, really nothing, but it's just the idea of keeping everything working the same. So now, how many times will x go into x squared? If we reduce, we see x, so put your x here, multiply back. X times x will be x squared, and x times negative 1 will be negative 1x. Now change signs and add. And 0 plus x is 1x, pull down. And now how many times will x go into x? Well, that would be exactly 1. And put the 1 on the line and multiply back. 1 times x is x. 1 times negative 1 is minus 1. Change signs and add. And of course we get remainder 0 here. So that means that x minus 1 went evenly into x to the third minus 1. And our quotient is x squared plus x plus 1. Okay, on this one, I have 3x to the fifth minus x to the third plus 4x squared minus 12x minus 8, and we're dividing by x squared minus 2. So when I set this up in the doghouse, notice that I've left a space for the 0x to the fourth, and I'll put my x squared minus 2 out here. Okay, so this one is a little different because the thing that we're dividing by is x squared minus 2, and there's a x power missing. That's actually okay. It does make our job a little harder here, you'll see when we get going. But if you just simply keep doing the steps and keep everything lined up, this one, even though it's a little more complicated, is the same thing. So let's make our initial guess. How many times will x squared go into 3x to the fifth? Well, if I reduce this, I get 3x to the third. So I'll put that here as my guess. Now let's multiply back. 3x to the third times x squared will be 3x to the fifth. 3x to the third times negative 2 will be minus 6x to the third. Now notice it's x to the third, so I do not want to line it up under my x to the fourth term. Let's line it up under x to the third. Okay. Change signs and add. And we get negative x to the third plus 6x to the third is 5x to the third. Notice that if I pull down the 0x to the fourth, it's still just 0. And here, of course, that adds up to 0. So now I've subtracted, I'm ready to pull down. Pull down 4x squared. Say, how many times will x squared go into 5x to the third? Well, 5x to the third over x squared reduces to 5x. So I'll put that here as my guess. Multiply back. 5x times x squared gives us 5x to the third. 5x times negative 2 gives us negative 10x. Now notice I've lined it up over here. I'm going to go ahead and change signs and add. Okay, when I add my 5x to the third minus 5x to the third adds up to 0. I don't have anything to combine with this 4x squared, so I keep it, and then my positive 10x, and now I'm ready to pull down this negative 12x, and let's combine like terms. I just see here that I've got a 10x and a minus 12x, so this is what we're running into that we have not run into before. The term that we had left over from the last go-around and the term that we just pulled down are the same power. They're like terms, so we may as well combine them before we go forward. I'm just going to mark it out and show that 10x minus 12x is minus 2x. Now I'm going to do my division. X squared will go into 4x squared 4 times. I'll put that 4 up here as my guess, and now I'll multiply back. 4 times x squared is 4x squared. 4 times negative 2 is negative 8. Notice that I did not line it up under the x because they're not like terms. Okay, now change signs and add, and we'll have negative 2x plus 8. And now we'll bring down this negative 8. And notice that if I combine my terms, I'll have negative 2x, and that's it, because the 8 and the minus 8 will add up to 0. And here I'm ready to go again, but this power is bigger than what we have left, so this will end up being our remainder, and we'll use that as the top of our fraction, and of course x squared minus 2 is the bottom. And so our quotient is 3x to the third plus 5x plus 4 minus 2x over x squared minus 2.